Hello and welcome to General Chemistry 1301. My name is Jonathan Tipo and today I'll be going over Module 1. So you'll be hearing my voice through significant figures, scientific notation, SI units, dimensional analysis, and properties. So, get ready to hear my voice so many times. Well, let's get started. Our first topic is significant figures. Oops. So what are significant figures? Significant figures are the number of meaningful digits, so the number of meaningful digits, and I'll get to that in a moment. It also measures how precise a number is. And so this is actually the most basic and the most fundamental thing you have to learn in chemistry. So without significant figures, you can't really progress too well. So what do I mean by meaningful digits and preciseness of a number? So say we're going on a hike, right? Going on a hike and we find this cool green rock. Take it home. We actually have two scales at our house. We have a black one and we have a blue one. So we put our rock on our first scale, which is the black one, and it says 5 grams. Pretty cool. Move it to the second scale, and it shows that it has 5.032 grams. Right? So which is more precise? Obviously, it's this one, because we see more digits after the decimal. And so that's what I mean by how precise a number is. Because this has more significant figures, this means it's more precise. And that correlates to the second one. But what do I mean by meaningful digits in a number? Right? So let's say we had this third one. Let's do it in purple, right? Have this third scale, and this scale is super cool because it can show 100 digits, 100 numbers after the decimal, right? And so we move on this rock, we take this rock and we move it here, and it shows that it's actually let's do it in blue. It's actually 5.03256 or 6721000400. You get the idea. At what point does these numbers, what point do we not care anymore, right? There's only so precise that we actually want. It's just a rock. So yeah, this is why significant figures come in. We know, because we know there's up to a certain point that all these numbers that come after, it doesn't matter, right? And so that's what significant figures tell us, right? Because as cool as it is to know 100 digits after the decimal, it's just not that practical. So there are a couple rules to finding out how many significant figures a number has, right? So rule number 1, non-zero numbers are always significant, right? And I have the 1, 2, 3, 4, 5, 6, 7, 8, 9. Rule number 2, zeros between two significant digits are significant as well. It's what I like to call the sandwich rule, right? Because you got a zero kind of sandwiched in between two significant figures, which also make it significant. So number 3, trailing zeros after the decimal is significant. And this is what I said, kind of relating to our rule, kind of relating to our little rock example up above, right? So if you look here, we got 2 zeros after the after the decimal point. This is what we call trailing zeros. If it's after the decimal point, my bad. If it's a 0 after the decimal point, it's a trailing 0. And that makes trailing zeros significant, right? And let's look at these two numbers. What's the difference between these two numbers? Well, because of something called rounding, we know that this rule, or this number, is more specific, because we don't know, where is this? We don't know if this number is actually 5.01, 5.02, or even 4.99, right? These are 3 different numbers. But we know, because this number has more significant figures and more trailing zeros, that it's specifically 5.000. Right, and so that's why trailing zeros are significant, because the more trailing zeros you have, the more precise a number is. All right, number 4 and 5, these rules are kind of rare for you to be tested on. They're kind of good to keep, in the back pocket, but I would really remember and focus all my energy on these top 3 rules, because number 4 and 5, they counter each other, right? And you're rarely going to see this on a test. But it's helpful to remember that numbers greater than 0 with a decimal point, all numbers are significant, right? So all of these are significant. There's 4, there's 2, and there's 4 because of this decimal point. And numbers greater than 0 without the decimal are ambiguous. So 40 is actually like 1 or 2. So same goes with 50, and 100 would be like 1 or 3, if that makes sense. Cool. As I mentioned something, rounding is a big part of significant figures. So let's give a refresher on rounding. So if the number is 4 or less, you round down. If the number is 5 or higher, you round up. So what do I mean by that? Right, say we have this number 5.0325. Let's do our rock example. And we want to round to the tenth. That's tenths, tenths place. So this number will return into 5.0. Why? Because this number, the number that comes directly after the place you want to round to, it's 4 or less. So that means it rounds down to 5.0. I'm not going to spend too much time on this because this is kind of something a lot of people should know at this point. But again, if you have any more questions, please refer to this video or even just ask your peer leader. I'm sure they'll be able to help. So on the same topic, if it's 5.525 and we want to round to again to the tenths, we would look at the number afterwards and see if it's 5 or higher. Because that's 5 or higher, we round that up to 5.1. Pretty simple stuff. So let's do some examples, right? Examples. How many significant figures are here? So there are 3. Let's do this in green. There are 3. Why? Because we got 2 non-zero numbers and we got the sandwich rule. What about this one? We got 5. Well, because 5 non-zero numbers. What about this one? This one. We got actually just 2 significant figures, right? Because we have 1, 2 non-zero numbers along with all these extra zeros. And remember how I said about trailing zeros not being significant or being significant? Well, these are actually not significant because there's no decimal point before. They only become significant if the decimal point comes before all the zeros. But since these are zeros without the decimal point, they're not significant. So let's do this one, 002. Well, there's only one significant figure here. Why? Because these always leading zeros are always not significant, right? If a number starts with a 0, it's not significant. And if you think about it, all these numbers are the same, right? 002, 02, 0, or just 2. All these numbers mean the exact same thing. Because there's only one significant figure, and the zeros right here, you can add as many as you want. It's not going to change the number. And so that really is the idea of significant figures, right? Because no matter how much zeros we add before a number, they just don't matter. Let's look at this number, or this number. Oops, kind of give you the answer, right? Because that's 5 significant figures. Again, leading zeros don't count. You got 1, 2, sandwich rule, and trailing zeros. All right, so that's 5. And this one, 3. Pretty simple stuff, right? So let's go on to calculations, addition and subtraction of significant figures. So there are rules kind of like PEMDAS where it's separated with subtraction, addition, and multiplication, division. I'll get to those in a moment, but first let's concentrate on addition and subtraction. So these are the steps. Step 1, do normally, right? So let's do 642.32 plus 5.5 5056. Alright, I just made this number off the top of my head. Alright, so let's do it normally. So we would get 642 plus 5.5056. We would get something that looks like 647.8256, right? Then we would look at what number has the least amount of significant figures after the decimal point. So what I like to do is I like to draw a little line at the decimal point. And so we see we have 2 significant figures here and we got 4. So that means we only want to go up to 2 significant figures after the decimal point. Right? So that means we go 1, 2. And we're going to round at this number. So at the end, we'd have 647.83, right? Because this is 5 or higher. 647.83. You know, and that's how you do it, right? Pretty simple stuff. Let's do one more. I'm going to make this number off the top of my head. 808,662 plus 667.8910. Right. So let's look at this. Draw our line. Draw our line. Let's do it normally. Right. Let me move this off to the side. So let's do this normally. Plug this into our calculators, and what do you get? You get 1476.553. I'll just do it twice for good measure. 0.553, right? So we look at this and we see that this has 3 significant figures and 4 significant figures after the decimal point. So that means we're only going up to the 3rd significant figures. Lucky for us, this only goes up to the 3rd significant figure, right? Because, you know, if you did it, you know, if you stacked it up like how we did it in elementary, we'd have that 0. But because we know that we're only going up to the 3rd significant figures, we drop that 0, and your calculator actually does that for you. So it drops that 0, leaving us with only 3 significant figures. Alright, pretty simple stuff. Division and multiplication. So find the number with least amounts of significant figures, do the problem as normal, and then you round the answer to fit significant figures. Pretty simple stuff, right? So this is kind of tricky when you do this at first, but let's do it. So 64 times 2. Don't get ahead of me. Let's do the steps first. So first you find the number with least significant figures, 1 versus 2. Because there's one significant figure and that's a number with least, that means our answer has to also be 1 significant figure. So let's do the problem normally. So you should be getting like 128. Right? So after 128, we use this to find out how many significant figures there are. Right? And so you always start, you know, left to right, kind of like you're reading. So we want this to be 1 significant figures, and since these two match up, we just stop there. So let's drop this 1 and add our 2 zeros at the end. Cool. So that's basically it, right? So our 100, and I know this doesn't look right in your brain, but trust me, when it comes to significant figures, the answer will be right. Let's do another one, right? Another one for good purpose, good measure. 1, 2, 3 times 4, 5, 6, 7. Right? Rule number 1, always look how many significant figures there are. So it's 3 versus 4. Rule number 2, do as normally. So that's 1, 2, 3 times 4, 5, 6, 7. That's 5, 6, 1, 7, 4, 1. Right? So we want to round this only up to the 3rd significant figure. So that's 1, 2, 3. Let's round to this area. So because this number is higher than 5, that means we round up. So our answer is looking something like this. Has a 0 at the end. 562000, or 562,000. So mixed operations are the last thing that we have to go over, and they're pretty easy. You just do it as you go along, right? So let's do something simple. 4.0 plus 6.67 times 2 times 201, and then you add 6. That's an add. 6.23. Alright, and so let's do this as we go along. So first, we do this. So what is our answer when you do 4.0 plus 6.67? If you're able to do mixed operations, that means you have a really good handle on this whole situation. If not, I mean, that'll be your test to see if you really mastered significant figures. So you have 4.0 times 10 to the 1. So this would be 10 point, I'm sorry if you can hear my dog in the background, 10.67, right? But since we're only going to one significant figure after, this becomes 10.7 times 201. Everybody understand how I did that? Right, so let me backtrack. Let me do this again for people who didn't understand. You do this normally, which is 10.67. We're only going to one significant figure after the decimal point, which means we want this one. And we use the next number to round, right? So that's where I got 10.7. So 10.7 times 201. Next, you do this part. So 10.7 times 201. And really, this is just doing it as you go on, right? And so there's 3 significant figures, 3 significant figures. That means our answer should also have 3 significant figures. So when you do this, we actually get with 2.50.7. But since we're only going up to 1, 2, 3 significant figures, oops, let me try that again. 3 significant figures, that means our answer is 1.0, or even you can just drop that off. Right, and so lastly, you do that. And how many significant figures after the decimal point is there? Well, this one actually doesn't exist, so there's 0 significant figures after the decimal point, which means our answer should only also have 0 significant figures after the decimal point. So we're looking at 1.5625. Drop these things. So we're looking at 2156. Right, and again, mixed operations pretty easy once you break it down step by step. But that should be the end of this video on significant figures. If you need any more help, please look at your module workbook, your module in your workbook, or just talk to your peer leader. I'm sure they'll be happy to explain this to you. So that's about it, and we'll see you in the next video.